Take a look at this line. This is a $100 million line, probably the most expensive math equation in history. It's a limit, an imaginary wall of physics and mathematics of how intelligent artificial intelligence can ever be. So take a good look.
Because I promise I'm not gonna show it again in this video. Like, I'm not pretending this is a science channel, so we're not gonna go that deep. But I will explain, in the simplest of words, why there's a limit to how smart these models can get, a limit that even the top scientists have not been able to overcome. And the clues about this have already started to show up. And this is the equation, that was the equation that might put an end to all this bubbly behavior around AI. So for years, we've been imagining an artificial intelligence that outsmarts us. But let's get something out of the way. Computers are already way better than us at plenty of things. Computers absolutely kick our ass at solving math, and they're definitely smarter than us at storing data and reciting it back. That's not really intelligence. Current AI companies have even had to differentiate our current AI from AGI, artificial general intelligence, because they know deep down that what we have now is not really intelligence. But assuming that we gave hands to a GPT, could it actually cook me an egg for breakfast? Hold that thought. The fact that AI is the buzzword of the year and that NVIDIA is worth some $1 trillion number is based on three premises. One, that the smarter models are gonna need all of those GPUs. Two, that more people are gonna adopt AI into their daily lives. And three, that our AI models are gonna get exponentially smarter. Everyone is in panic mode because some Chinese startup allegedly built and trained a ChatGPT level model using a fraction of the compute cost and a fraction of the cost.
One Chinese startup just launched a new AI model to rival OpenAI.
DeepSeek has become the most downloaded free app,
passing ChatGPT, which is pretty shocking.
I'm gonna get to this. It remains to be seen how much the average Joe or the average company adopts AI into their lives, but none of those betting on big tech's AI transformation are even questioning the possibility of that third bullet point. And therein lies the problem. Making our current AI models smarter is almost impossible. In order to understand why that math equation is so dangerous to these companies, we need to understand at least the basics of how our current models are trained and how they think. So let's just go to our explainer time.
Explainer time.
What GPT excels at, to the point where it acts like an intelligent, sentient bot, enough to fool many of us, to write entire essays, what it does is predicting the next word in a sentence. But being really good at predicting words, or the next word, already allows a model like GPT to beat us at most standardized tests, which is kind of the way we measure our own human intelligence, isn't it? And yet, GPT doesn't do that well at math. It only beat about 50% of the students in these tests. Why is that? Well, one number that you're gonna hear about all the time when people talk about these models is the number of parameters that a model was trained on. How many parameters is a model using? GP3, for example, which is almost useless, dumb compared to the models that we use today, used 175 billion parameters. What the hell does that mean? So, let me show you. Now, a model like GPT uses pre-trained transformers to generate text, hence the name. Now, this sounds like nonsense to you right now, but I promise it'll make sense in exactly 4 minutes. Imagine that we feed the model a sentence so that it can try and predict what the next word is. So the first thing that the model needs to do is try to understand what this group of words mean. Like we're seeing words here, but the computer is really just seeing bits out of all this thing. And the first thing that the model will do is try to break this into tokens. Maybe you've heard the term before. Then what it'll try to do is classify those tokens based on their meaning. LLMs classify words by grouping them together with words that have similar meaning. Technically, this is done not by grouping entire words, but tokens, which are fractions of a word, but I'm gonna stick with the concept of words just for simplicity's sake. For example, ring may be classified with other words like ear, like jewel, maybe around the world circle. So here's a 2D, simple two-dimension axis. We have a horizontal axis X and a vertical axis Y. And this is great for numbers, right? Because we can just go up or down depending on the number, but we're dealing with words here, and there are thousands of words out there with thousands of different meanings. It would be kind of impossible to group words by meaning into a 2D space. Even in a 3D space, we'd run out of directions to go to very quickly. So GPT-3 classifies words, or tokens really, into 12,288 different dimensions. That means a grid with 12,288 axes. We can't see it, of course, we can't even imagine it. It's like that interstellar tesseract, but with 11,284 more dimensions to go. But don't worry, what you need to understand is that in this unimaginable cloud, this black hole of directions, words with similar meanings are gonna be grouped close to each other. So from the GPT-3 paper, we know that OpenAI used about 50,000 tokens, basically a dictionary of tokens, and it mapped them into this 12,000 dimension space, which already puts the count of parameters that the model's gonna need at around 600 million. Still, that's far from the 175 billion parameters that GPT-3 had, so let's keep digging. But before I do that, I want to take a moment to thank NordPass for helping us fund today's explainer. NordPass is a secure password manager created by the experts behind NordVPN to help you and your team store and share passwords and credit card details securely. 1 in 4 people can still log into accounts from their previous jobs, granting them access to stuff that they shouldn't have. But passwords shared through NordPass can be revoked in seconds. You have full visibility into who has access to which shared company accounts and the vulnerability of these, making life a lot simpler for your IT departments. We migrated our old password manager into NordPass with a simple export-import function, and everybody hit the ground running in minutes. It's easy to use, you can sync it across devices, and it has this user-friendly interface, so I really can't recommend it enough. NordPass also has this really cool feature called Data Breach Scanner, which gives you live alerts if any of your corporate data appears on the dark net. So it gives you a warning in advance to change your passwords before any of your accounts are breached, which can of course cause financial and reputation damage. We partnered with NordPass to bring you a 3-month free trial on NordPass for Business and 20% off their business plans. No credit card is required. You can just go to nordpass.com/slidebean, use the code slidebean at sign up, or you can just scan this QR code. You'll level up your business security, you'll save a lot of money, and you'll help our channel in the process. Okay. So now let's dig into what happens after the embedding. So the mapping of words into this incomprehensible tesseract black hole is called embedding. This is the embedding step. And it's how a model turns words into something that computers can understand, and process. But just understanding that the word ring lives in a neighborhood of other words, we still don't know what it means in this context. Ring might be a sound, might be an earring, might be the one ring. So how does the model know? And so that's where transforming comes in. What the model's gonna do is transform the word, essentially move this word in this 12,000 dimensional space. This specific sentence, it'll move it closer to the meaning that's based on the context around this specific word in this sentence. So that context could be the word before, the word after, could be the words mentioned earlier in the conversation. For example, the model might notice that this R is capitalized, even though it's not at the beginning of the sentence. Must mean something. It might also look at adjectives and how they affect nouns. So this transformation layer makes tiny adjustments in the region of space where this particular word lives. Now, all of these transformers are gonna run at the same time. And that's in part why GPUs are so good at doing this thing, because they were built to calculate all the pixels in your screen at the same time. Now, each transformer in GPT-3 has about 1.8 billion parameters. Around 600 million of those parameters are in this first attention layer, which helps focus the word in space, and about 1.2 billion of those parameters are in the feed-forward network layer, which is kind of like a zoom in on the meaning of the word, but that's as far as we're gonna zoom in today. Now, GPT-3 uses 96 of these transformers for a total of almost 174 billion parameters. We're almost done. Now, the last few parameters are on the output layer, which essentially does the unembedding, the inverse of the input layer. It brings this word, these 12,000 dimensions, into our old 2D bit world, and it gives us the result of this massive operation of the model as words, not as numbers. The result of this massive mathematical journey is a list of words along with the probability of which word comes next. Now, the whole idea of machine learning is that we don't have to go to train each one of those 175 billion parameters to tell it what it needs to do. It learns itself, aka machine learning. Now, the first time this runs, this thing is gonna spit out just gibberish, but during training, the model adjusts these parameters using algorithms to reduce these errors. Think of them like small knobs that slightly move to generate slightly different mathematical outcomes in the end. It's like trial and error on a trillion scale. If a particular set of values helps the model make a correct prediction, those values are reinforced. If not, they're adjusted. Each of these connections between one value and the other is a neuron, which makes a neural network. And it works not so differently from human neurons. Like, it may sound impossible, but after billions of operations and training data, this thing can actually and pretty accurately predict the next word in a sentence. Again, this thing has consumed billions and billions of text written by humans and has become so good at predicting words that it can pass our tests. And predicting words is the LLM example, but you can apply this logic of predicting the next thing at how a pixel should look to generate an image, or understanding if this dress is blue or gold. Same basic principle. Now you know the reason why it failed the high school math exam. A pure GPT model doesn't
Smile and learn.
Not directly. In the simplest of terms, if you ask it what's 1 + 1, it knows the answer is 2 because it read 1,000,000 times that the answer is 2, and it's incredibly efficient at identifying patterns, but not because it pulled up a calculator and added 1 + 1. That's not bad per se, but it's gonna be a problem later. The thing is, once you have a computer that can understand these relationships within words, you can give it instructions in plain English, and it'll base its responses on that. Like this transformer model with an instruction on top of it is the same concept that Grok and Llama are using, and they're all limited by the same equation. Now that 175 billion parameter GP3 model had problems. Like you could tell it was AI because it didn't write quite like a human. It couldn't count the R's in strawberry. It also had a rather small limit of context. How many tokens before the current word are processed and considered for the prediction of the next word. So let's just train it with more, right? OpenAI theorized that by scaling the amount of data and the amount of parameters, the model would get a lot smarter. And it did. A way to measure the effectiveness of the model is with the error rate, so the word predictions that are incorrect. In very simple terms, it's more complicated than that. But anyway, they projected the error rate decreasing the bigger the model was and the more data was used for its training. And so they went and did it. They spent over $100 million in training this thing. Leaked data from OpenAI says that GPT-4 uses 1.8 trillion parameters. It has more transformer steps, potentially with more dimensions for the tokens. And it took about 25,000 GPUs running for over 3 months to train GPT-4. But it worked. The results were way better than GPT-3. So let's just keep doing that, right? More GPUs, more data, more parameters. Well, that's when they hit a wall. Now that wall is this formula I said that I wouldn't show you again, because you would think that a bigger model, in this case, the bigger the size of the model, the better.